Okay, I'll continue where I left off in the previous video. We finished parts A and part B. Now for part C, I'm just going to erase some of this stuff at the top. What we're trying to do for part C is to use a left Riemann sum with subintervals indicated by the data in the table to approximate the integral from 2 to 13 of f of x dx. And again, there are different ways of looking at this. You should understand that what this is doing is making rectangular areas using the points and then using those areas to approximate the area under the curve of the function. So we're going to quickly plot these points. It takes some time to do this, so as I go on, I won't usually go through this process. And so we have these points with a left Riemann sum. We're going to use the left endpoint of each subinterval. So from 2 to 3, we're going to use a height of 1. And from 3 to 5, we're going to use a height of 4. Then from 5 to 8, we use a height of -2. From 8 to 13, we use a height of 3. And we never wind up using the last point. In a left Riemann sum, you never use the last point. In a right Riemann sum, you never use the first point. So our first rectangle has a width of 1 and a height of 1, so it has an area of 1. The second rectangle has a width of 2 and a height of 4, so it has an area of 8. The third rectangle has a height of -2 and a width of 3, so that has an area of -6. And the fourth rectangle has a width of 5 and has a height of 3, so that has an area of 15. So to approximate the area under the curve from 2 to 13, all we're going to do is add up those rectangular areas. 1 plus 8 is 9, plus -6 is 3, plus 5 is 15. And we're going to state that the integral from 2 to 13 of f of x dx is roughly equal to 18. And our work would be the graph. So again, in your workbook for the AP test, you're going to have lots of space. I'm trying to fit this all into the little space that I have here. Now another way of looking at this that doesn't involve actually going through the graphing, we'll just use the table of numbers. We have 4 subintervals, from 2 to 3, from 3 to 5, from 5 to 8, and from 8 to 13. And we're just going to make rectangles with those intervals with those numbers as the width of the interval. So for example, for the first interval, we have a width of 1. For the second, a width of 2. For the third, a width of 3. And for the fourth, a width of 5. For the height of each rectangle, we're going to use the left endpoint in each subinterval. So in the first subinterval from 2 to 3, the height is going to be 1. We use the left endpoint. In the second subinterval from 3 to 5, we're going to use 4, which is the left endpoint of that subinterval. In the third, we're going to use -2, which is the height, which is the left endpoint of that subinterval, and finally we're going to use 3. And so what we end up with then is a series of areas that relate to those rectangles that we see in the diagram we drew. So we have a width of 1, height of 1, so it's 1 times 1, a width of 2, height of 4, so it's 2 times 4, a width of 3, height of -2, and a width of 5, height of 3. So multiply all those out and add them up and you'll get 18. So there's a way of doing it just by looking at the table of numbers and using the information that's provided that we're using the left endpoints, and that may save you a lot of time to do that. So there's a couple of ways of looking at that particular one. I will choose the second method. Once you understand how the graph relates to the areas, you can go right to the numbers and not have to take the time to graph that out. So I'll continue with part D in the next video.